Well, howdy folks. So today we have an autopsy. So I've had a little go at this already. This is sort of a recap video rather than a do it in front of the camera video. But nonetheless, I learned some interesting things and hopefully you will too. So here we have this thing. This is a 10-Viz JPT 3815W wireless security camera. So the idea with this is, you put it somewhere and it's got this rotating head, camera, some IR LEDs for night vision, whatever the hell that is. We've got wireless antenna and just basically power and 100 megabit Ethernet, and that's it. It's wireless G only, which is kind of shitty because it means you've got to put your AP into legacy mode because pretty much everything's N now. Which is kind of shitty. But anyway, long story short, it crashed a lot. Basically, you'd plug it in, it worked for a couple days, and then the web interface would just no longer exist, basically. So you'd have to unplug it, plug it back in again, and it would work for, again, a couple days, and then it would die. So there was a firmware update on 10Viz's website, which is horrifying, by the way. It's basically just a forum page with a little table so you can find the right image. So I flashed the new firmware, and there was no video in the new firmware. In fact, every time you clicked anything in the interface, the whole thing would reboot. So I tried to, reset to factory defaults, right? Maybe to try and fix it. And that bricked it. Now there is no web interface at all. It just rejects all connections to it. You can ping it. I mean, it's alive, but the web interface, whatever runs that, is now totally fucked, and I'll get into that in a little bit. So anyway, so it's bricked, so I took it apart, and here's a circuit board, and this is the interesting part. But basically, the unit has a bunch of shit coming out of it. Crappy coax for our wireless. We have a limit switch here, which is just so that it can tell how rotated when it gets to the end of its travel. We've got 4 wires here for the motors, and we have another 4 wires, which is actually a USB connection. Because as I found out, this camera is just an off-the-shelf VGA webcam that they've connected via USB into the device. I forgot to mention there's actually a photocell here, which controls the brightness of the lights, but I don't think that is controlled by any circuitry on this board here. I think that's all done just passively, like an analog, up in the head here. So this is completely irrelevant and useless now. So this is the board. This is where stuff actually gets interesting. So as you can see, we have our Ethernet jack, we have an audio out, which is just a headphone jack, we have our magnetics for our Ethernet, we have our power in, there's a little bit of DC to DC going on here, we have all the headers for all the different cables you just saw. Down here we have, this is 16 megabytes of SD RAM, and on the back we have 8 megabytes of NOR flash, stupid reset button. And of course, the heat-sinked chip here, this is a Raylink RT3050 access point system on a chip. So this is basically a MIPS processor, runs at 360 megahertz, and it's coupled to all the memory, it's coupled to the USB, it's got USB on the go support, which is probably what they're doing to get access to the webcam. It's got wireless N capability, which is interesting given the fact this is only a wireless G device. And my best guess as to why that's the case is that 10Viz, the company that makes this, probably couldn't get a working N wireless driver for Linux. This thing runs Linux. And I get the feeling they had a flaky N driver and they were like, fuck it, let's just use G because it works and it's a camera, who cares? I mean, I think that's it. But it does have N support. It has 150 megabit total network bandwidth, so that, for N. It has a 7-port switch in it. Of course, they're only using one of the ports of that for this. So it's kind of interesting, the way that they've done this, but of course it's all built down to a cost. So the first thing that I did after I ripped it apart was I tried to find a serial port, because obviously knowing a device like this, just thinking it's, I didn't know all this at that time. I mean, there's no way you can get it from this board. I got this all from the serial port. I assume that there's got to be one. And there's 2 unpopulated headers. There's one here, which has nothing on it. And then there's one here, which, as you can see, I've soldered 3 wires onto it. And there's a 3.3 volt CMOS serial port output on this. And you find the baud rate is 56,400, if I can remember correctly. It was a while ago when I did this. But basically, I just hooked it up to my USB converter and plugged it in, and we get a U-boot, actually, U-boot version 3000. So it gives you the option if you want to do a TFTP boot, or if you want to do, you know, there's a bunch of little recovery things, and then of course it automatically boots after about 2 seconds. So it loads a LZMA compressed Linux kernel from the memory, which is only about 4.6 megs, decompresses it, starts running that, and it goes into Linux. And because there's only one console, if you actually just press enter a couple times to clear all the kernel messages out, you get a root BusyBox shell, which is excellent. And I did a little bit of probing around. That's how I sort of figured out how they were doing all sorts of things. They've actually mapped the motors to a device in /dev/motor, which is interesting. You know, basically everything's handled by BusyBox. There's only really one binary on there that's not part of BusyBox, and that's or part of the kernel, and that is the web server. It seems to be written in C of some kind. There's actually a full installation of GDB on this, which I actually used. I connected remotely over the network to it, and I tried to find some sort of anything I could find to figure out maybe why it wasn't working, because I could start it manually even in the console, and it wouldn't work. I couldn't get anywhere with it. It has a telnet server on it, which I could spawn, and I could talk to it over telnet. I mean, there's a lot of security flaws in this thing. I know a lot of people have documented some of the crazy shit you can do with these and how they're not password protected in any way. So I mean, I have no interest in getting this thing working again. I don't care. But it was interesting to try, at least. So I thought, okay, I've got the U-boot, so why don't I just, I have a TFTP server. Why can't I just, get a different image and flash the thing that way? So that's exactly what I tried. So I tried to find the old version of the firmware for this, and I was able to find it. It's not on Tenvis's website, but some other people had mirrored it. So I tried that, and I could get it into RAM. I could get the thing to start booting it. It would start booting the kernel. It would try uncompressing the kernel, and would always fail with LZMA error 1. And it's not just that image. Every single kernel image that you try on this thing will fail the exact same way. You cannot boot any kernel but the one that's on the NOR flash. I cannot figure out why. I mean, there's no reason why, but none of them work. So I can't get the new kernel, and if I can't change the kernel, and if I can't change the kernel, I mean, I really can't do anything. And I'm not about to flash directly to NOR. I mean, I might do that considering I don't care, but there is an option to do that, to flash, I think, directly to NOR rather than flashing into memory and trying to jump into memory. I mean, I've tried to putting the kernel at different places in memory. That doesn't work either. So I mean, I can't figure out why it won't decompress. I'm not sure if there's a bug in U-boot or something. I honestly don't know. The interesting thing about this is maybe why it failed. I kind of wanted to look online to see if people could, if anybody had the same issue. And as it turns out, that's doesn't actually seem to be anyone's had this issue, which is kind of strange. So maybe this is just a one-time thing. But what I did sort of learn from reading blogs and other sort of things is originally, I don't know what that means, but probably at the beginning of this new, I think it's firmware version 1.4, whatever, they released it in 2 parts. There was what they called a small update and big update. There were 2 files, small.update, big.update. And the idea was you would flash the small update, reboot the device, then flash the big update through the web interface. And when you go to their website now, there's only one file for this product, and that's the big update file. And I thought that's kind of interesting. I was never able to get a copy of those 2 small and big files. Actually, no, I was able to get a copy of the small files, but the small file didn't uncompress, so I couldn't go anywhere with it. Anyway, I bin crawled through all of them, and I opened them in hex editors, tried to figure out what was in them. The small.update is a MIPS kernel image, and the big update is just some sort of binary blob which seems to contain like just program data. So the way I guess it is the small update is a new kernel and the big update is a new software package, and they somehow couldn't fit this into one image somehow. I don't honestly know why it's two pieces, but it is for some reason. And I think that might explain why this is bricked now, because it's probably running a new software package, because the big update succeeded when I did it, when the device still worked. So the big update probably put a new software package on this, even though now it's got an old kernel, and there's probably some stupid incompatibility between the new web thing and the old kernel, and that's probably why everything is why it's probably not booting. I mean, I can ping the thing, I can do telnet over it, I can GDB over it, I can bind to different ports. I mean, there's nothing wrong with the networking. It's just the web server application just does not want to start. So, I mean, if anyone has any ideas of things maybe I haven't tried yet, things they want to see me try, I mean, I don't care. I mean, taking a hammer to this or putting 270 volt mains, because I got a Variac, I mean, I could put 270 volt mains into this. I mean, just, leave it in the comments. Tell me what you want to have. Tell me what you want to do to this. I mean, there's also this. I mean, I don't care about this either. There's a camera in here. Some motors. These motors are, I mean, they don't look like stepper motors, and they actually might not be stepper motors. I haven't tested these yet, but they don't look like stepper motors. So what I think they might be is, because there's 4 wires here, I think what might be going on is it's just power, and then maybe there's just like a linear potentiometer in here just to tell it where it is. Maybe I don't know. I haven't taken the motor apart or tested it, and I haven't taken the head apart, because that's going to be a pain in the ass. And I just honestly don't care. I mean, it's a piece of crap. So honestly, if I were you, I probably wouldn't buy this. Not only because I think, for a little bit more money you can get a lot better of a product. The video on this was crap. And of course it's insecure as fuck. So anyway, at least there's a little bit of cool stuff. I might, if anyone wants it, I can post logs of all the stuff I captured off the serial port, and maybe a file system tree and things like that if people want it. But I mean, these aren't that hard to hack, as long as you know where the serial port is. It's the lower 3 pins of that header there. That's S port 1. Serial port 0 is actually not broken out under the BGA, so you can't get to it, but I doubt the kernel would even use it if it's not broken out. They probably haven't programmed it that way. So anyway, let me know what you want, and thanks for watching.